Hello guys, and welcome back to my YouTube channel, Data Analytics with Saeed. And today we're going to talk about what is exponential, log, and hyperbolic in NumPy. So in NumPy, it provides a variety of mathematical functions, including exponential, logarithmic, and hyperbolic functions. Here's an overview of each. So what is exponential in NumPy? In NumPy, the primary function used for exponential calculation is np.exp. This function computes the exponential for all elements in the input array. It's based on the mathematical constant approximately 2.718, where x power x represents the exponential function. So the this is the value of E. Almost, it's about 2.7718. So now we're gonna calculate it. First, we're gonna show you guys what is the exponential function, and then we're gonna code it. So the function NumPy include npxp2 and npxpm1. So npx normal is calculates the exponential of all elements in the input array. E equals x. So E, but a power of 2, it will show us like what it is. np.xp2 calculates 2 raised to the power of x. So E power of 2. So that's gonna be, let's say like it says 2.7 and we times 2.7 times 2. That will probably be like 7. And 7 times 7 again, that will be like almost like something else. So 49. np.xpm1 calculates the exponential of x and subtracts 1. So power of 2, that would be 7 minus 1, that would be 6, which is more accurate for small x. How to code the exponential function? So we do import numpy as np data e- equals brackets 1, 2, 3, 4, 5, 6, 7, 8. Now we do print np.xp data is now this is what I told you. So it will be E power of 1. That would be 2.718 because E times it by 1. It wouldn't give us a higher value. It would just give us the same value. Now if we do E power of 2, that would be 37.2 or something. So the output would be 2.7 for 1, 2 for 2 is 7, and 3 is here. Oh yeah, here. So w 1 is 2, as in 4. 2 is 4, as in 3 is 9. It's just all mixed up, but it will show you how it is. Over here, it's kind of mixed up. It says 1, 2, 4, 7, 1, 2, 2, 5. But these are all the answers, as 2.7 is 1, and uh, there's more. There's more such as 9 is 3. So that's how it works. I also calculated here how we can import it, and that's what we get. So calculate the logarithmic functions. So the functions are for what is log first. So in Python, you can calculate the log or logarithm of a number using the math module, which provides various mathematical functions. There are functions to calculate logarithms to different bases, including the natural logarithm, base E, and logarithms to other bases like 2 and 10. So what are the log function? This script demonstrates how to compute various logs. So first is math.log and x computes the natural log. Mathlog2 computes the log of x to the base 2. Mathlog10 computes like the log of x to base 10, and mathlog x, math.log produces x comma base computes the logarithms of x to any custom base. So how we can calculate it? We can calculate by import numpy as np.data. No, import numpy as np data equals 1, 2, 3, 4, 5, 6, 7, 8. Now we print np.log and data. Output will be 0, 0.6, 0.9. We don't need to go too deep. No, nobody really knows how to calculate this on their own mind. The computer mostly knows how to do it, but that's how it works. So now we're gonna talk about what is trigonometric in Python. Trigonometric functions in Python are part of the math modules, which provides a range of mathematical functions, including those for trigonometry. It's a quick rundown of some key trigonometric functions available in the math module. And the next slide, because over here there's a lot. So the functions in trigonometric are math, dot sin, dot cos, dot tan, dot ascend, dot arcos, atan. And now, yeah. So forget the last three. Those are for hyperbolic. So the first one, sin, computes the sin of x and radians. The cos computes the cosine of x and radians. The tan computes the tan of x and radians. Computes the ascend or the arc sine inverse sine of x, returning the results in radian. Math the arcos computes the arc cosine and inverse cosine of x, returning the results in radians. And lastly, map the atan completes the arctangent, inverse tangent of x, returning the results and radians. So it shows all of them, and it shows all of these here. Yeah, let me go back. So it shows all of these results and radians. So how to calculate it is we have the same list again, print np.send data and print np.cost data, and the output will give us the this first two. This first section is np.send. The next last section is np.cost. And we don't really know how to do this. Only the computer knows, but this is how we code it or calculate it. So now, lastly, we're gonna talk about what is hyperbolic in Python. So hyperbolic in Python, hyperbolic functions in Python, like their trigonometric counterparts, are available in the math module. These functions are related to hyperbolas in the same way that trigonometric functions are related to circles. The key hyperbolic functions include sin h, x, cos h, x, and tan h, x, along with the inverse functions. But these three are like the most important that we usually use a lot. So as you can see, there's a lot, but there's six here, but the most important, like, or the most like uh common we use is sin, cos, tan. So sin just computes the hyperbolic sine of x, cos computes the hyperbolic cosine of x, tan computes the hyperbolic tangent of x, asinage computes the inverse hyperbolic sine of x, cos computes the inverse hyperbolic cosine of x, and then computes the inverse hyperbolic tangent of x. So it just computes the hyperbolic sine of x, all of these in different ways. So how to calculate the hyperbolic Python? We can do it by print np.send data, print np.cosh data. Apple will give us this. So this is for send for hyperbolic, and cosh is the last two lines that is the value of data for cosh. So that's how we learned today how to what is exponential log and hyperbolic and numpy, how we can what are the different functions for each of them and how we can code them. So thank you for listening and watching this video, and subscribe to my channel, and I hope I can see you in the next video. Thank you. Have a good day.